Okay, hi everyone, welcome back to this video series on cryptocurrency, mining pools. In this highly competitive environment, individual miners working alone, also known as solo miners, don't stand a chance. The likelihood of them finding a block to offset their electricity and hardware cost is so low that it represents a gamble, like playing the lottery. Even the fastest computer ASIC mining system cannot keep up with commercial systems that stack tens of thousands of these chips in giant warehouses near hydroelectric power stations. Miners now collaborate to form mining pools, pooling their hashing power and sharing their reward among thousands of participants. By participating in a pool, miners get a smaller share of the overall reward, but typically get rewarded every day, reducing uncertainty. Let's take a look at a specific example. Assume a miner has purchased a mining hardware with a combined hashing rate of 14,000 gigahashes per second, 14 TH in 2017. This equipment cost approximately $2,500 USD. The hardware consumes 1,375 watts, 1.3 kW of electricity when running 32 kilowatt hours a day at a cost of $1 to $2 per day at very low electricity rates. At current Bitcoin difficulty, the miner will be able to solo mine a block approximately once every 4 years. If the miner does find a single block in the time frame, the payout of 12.5 Bitcoin at approximately 1,000 per Bitcoin will result in a single payout of 12,500, which will not even cover the entire cost of the hardware and the electricity consumed over the time period, leaving a net loss of approximately 1,000. However, the chance of finding a block in a 4-year period depends on the miner's luck. He might find 2 blocks in 4 years and make a very large profit, or he might not find a block for 5 years and suffer a big financial loss. Even worse, the difficulty of the Bitcoin proof of work algorithm is likely to go up significantly over that period at the current rate of growth of hashing power, meaning the miner has at most 1 year to break even before the hardware is effectively obsolete and must be replaced by more powerful mining hardware. If this miner participates in a mining pool, instead of waiting for once in 4 years 12,500 windfall, he will be able to approximately earn $50 to $60 per week. The regular payouts from a mining pool will help him amortize the cost of hardware and electricity over time without taking an enormous risk. The hardware will still be obsolete in 1 or 2 years and the risk is still high, but the revenue is at least regular and reliable over that period. Financially, this makes sense at very low electricity costs, less than 1 cent per kilowatt hour, and only at a very large scale. Mining pools coordinate many hundreds of thousands of miners over specialized mining protocols. The individual miners configure their mining equipment to connect to a pool server. After creating the account with the pool, their mining hardware remains connected to the pool server while mining, synchronizing their efforts with other miners. Thus, the pool miners share the effort to mine the block and then share in the rewards. Successful block miners pay their reward to a pooled Bitcoin address rather than individual miners. The pool server will periodically make payments to the miner's Bitcoin address once their share of their reward has reached a certain threshold. Typically, the pool server changes a percentage fee of the rewards for providing the pool mining service. Miners participating in a pool split the work of searching for a solution to a candidate block, earning shares for their mining contribution. The mining pool sets a higher target, lower difficulty for earning a share, typically more than 1,000 times easier than the Bitcoin network's target. When someone in the pool successfully mines a block, the reward is earned by the pool and then shared with all the miners in proportion to the numbers of shares they contributed to the effort. Pools are open to any miner, big or small, professional or amateur. A pool will therefore have some participants with small mining machine and others with a garage full of high-end mining hardware. Some will be mining with a few tens of kilowatts of electricity, others will be running a data center consuming a megawatt of power. How does a mining pool measure the individual contribution so as to fairly distribute the reward without the possibility of cheating? The answer is Bitcoin's proof of work algorithm measures each pool's miner contribution but set at a lower difficulty so that even the smallest pool miners will share frequently enough to make it worthwhile to contribute to the pool. By setting a lower difficulty for earning shares, the pool measures the amount of work done by each miner. Each time a pool miner finds a block header hash that is less than the pool target, she proves she has done the hashing work to find the result. More importantly, the work to find shares contributes in a statistically measurable way to the overall effort to find a hash lower than the Bitcoin network's target. Thousands of miners trying to find low value hashes will eventually find one low enough to satisfy the Bitcoin network target. Let's return to the analogy of a dice game. If the dice players are throwing dice with the goal of throwing less than 4, the overall network difficulty, the pool would set an easier target, counting how many times the pool players manage to throw less than 8. When pool players throw less than 8, the pool share target, they earn shares, but they don't win the game because they don't achieve the game target less than 4. The pool players will achieve the easier pool target much more often, earning them shares very regularly, even when they don't achieve the harder target of winning the game. Every now and then, one of the pool players will throw a combined dice throw of less than 4 and the pool wins. Then the earnings can be distributed to the pool players based on the shares they earned, even though the target of 8 or less wasn't winning. It was a fair way to measure dice throws for the players. It occasionally produces less than 4. Similarly, a mining pool will set a higher and easier pool target that will ensure that the individual pool miner can find block header hashes that are less than the pool target, often earning shares. Every now and then, one of these attempts will produce a block header hash that is less than the Bitcoin network target, making it a valid block, and the whole pool wins. I'll just move myself out of the way here a little bit. Managed pools. Most mining pools are managed, meaning that there is a company or individual running a pool server. The owner of the pool server is called the pool operator. He charges pool miners a percentage fee of the earnings. The pool server runs specialized hardware and a pool mining protocol that coordinates the activities of the pool miners. The pool server is also connected to one or more full Bitcoin nodes and has direct access to the full copy of the blockchain database. This allows the pool server to validate blocks and transactions on behalf of pool miners, relieving them of the burden of running a full node. For pool miners, this is an important consideration because a full node requires a dedicated computer with at least 100 to 150 gig of persistent storage disk and at least 2 to 4 gig memory RAM. Furthermore, The Bitcoin software running the full node needs to be monitored, maintained, and upgraded frequently. Any downtime caused by a lack of maintenance or lack of resource will hurt the miner's profitability. For many miners, the ability to mine without running a full node is another big benefit of joining a managed pool. Pool miners connect to the pool server using a mining pool such as Stratum STM or Get Block Template GBT. An older standard called Getwork GWK has been mostly obsolete since late 2012 because it does not easily support mining at hash rates above 4 GH. Both the STM and GBT protocols create block templates that contain a template of a candidate block header. The pool server constructs a candidate block by aggregating transactions, adding a Coinbase transaction with extra nonce space, calculating the Merkle root, and linking to the previous block hash. The header of the candidate block is then sent to each of the pool miners as a template. Each pool miner then mines using the block template at a higher, easier target than the Bitcoin network target and sends any successful results back to the pool server to earn shares. So I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.